Hello, I'm Don MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 34 for the week of August 26, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, August 26, the moon is 60% full in our southern evening sky, passing just south of Jupiter on August 28th, and then south of Saturn nearly a day later. By next Tuesday, September 1st, the moon will be full. It will be rising only about a half hour later each night as seen from the northern hemisphere, and it will be a factor in our evening sky until Saturday, September 5th. So why not observe the moon this week? For me, time spent looking at the moon is never time wasted. See what you can see, and try some cell phone photos while you're at it. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, August 26? It depends upon where you live. When the ISS passes by, in order for you to see it, 2 things must happen. It must be illuminated by the sun, and you must be in either darkness or twilight. When it does go by, people within 900 miles, that's nearly 1,500 kilometers in all directions, can see it. If it is not visible in your sky this week, it might still pass overhead, but it will be in daylight. When you are in daylight and can't see it because your sky is too bright, or in the middle of the night, yes, you are in a dark location, but the space station is not illuminated by the sun. It is only 260 miles, that's 420 kilometers high, so there are times it is deep in the Earth's shadow. This week we have 5 zones. If you live north of 45 degrees north, the ISS will be visible this week in your morning sky for at least the second half of this week, and for many of you, the whole week in the morning sky. Hungary, you will see it for most of this week. From 35 degrees north to 45 degrees north, this is a narrow region, the ISS will be visible for the whole week in your morning sky, sometimes twice per morning. Between 25 degrees north and 35 degrees north, the ISS will be in your morning sky for only the first part of the week. Japan and Florida, that is you. From 25 degrees north through 35 degrees south, you won't be able to see it at all this week. And that's like half the world's population. That is Sudan, India, Colombia, South Africa, and all of Africa for that matter. No International Space Station this week. South of 35 degrees south, it's in your evening sky all week long. New Zealand, look up. To determine where it will be in your sky, go to the website heavens-above.com and enter your location. Then click on ISS. Comet hunting. Centuries ago, before the invention of the telescope, comets were discovered by the unaided eye, also known as naked eye discoveries. The first comet discovered with the use of a telescope was by Gottfried Kirch, Kirch, on November 14th, 1680. For the next few decades, there were very few comets discovered with a telescope. They were found with the unaided eye. Charles Messier discovered his first comet in 1759, and this appears to be the first comet to be named after the discoverer. Charles Messier discovered 12 comets which bear his name, and one more that bears the name of the man who calculated its orbit, Anders Lexell. After Charles Messier, the next big comet discoverer is Pons, who found 26 comets. Pons holds the record for the greatest number of visual comet discoveries. It was during Messier's time, 1759 through 1798, that comet hunting became competitive. Competition ebbed and flowed throughout the centuries, with keen competition in the 1880s with Swift, Brooks, and Barnard, and again in the 1960s and 1970s. All of that has now changed. With the advent of search programs funded by various organizations and governments around the world, using telescopes to image the sky and search for asteroids and comets that might one day hit us, the era of visual comet hunting is coming to an end. Some would say that it is already over and that no more comets will be visually found. The last comet visually found was by me on November 7th, 2018. And it was later also discovered by 2 Japanese comet hunters using imaging equipment. For them, it was not a visual discovery. Prior to my find in 2018, the previous visual comet discovery was 8 years earlier. Back in the 1970s and 1980s, we were consistently visually discovering about 3.3 comets per year. So now, is it one visually discovered comet every 8 years? Most visual comet hunters have stopped their visual comet hunting programs and gone into other fields. Some, like Fujikawa of Japan, who co-discovered the comet I visually found in 2018, are using imaging equipment to search for comets. In the 1960s, 70s, 80s, and again in 2002, Fujikawa visually discovered 6 comets that bear his name. Now he's using imaging equipment for his searches. In 1798, Charles Messier discovered his 12th named comet. Some he discovered by telescope and some with his unaided eye. And in the course of time, he was the first person to visually discover 12 named comets. Do you know who will likely be the last person to visually discover 12 named comets? You're listening to him. It is I. I am still searching and do not know if I'll find any more new comets, but so far I've discovered 12 named comets. In about 260 years, we have seen the birth, growth, and death of telescopic visual comet discoveries. Now, in the history of humans, 260 years seems like a short time, but consider this. Visual discoveries of asteroids lasted even less time. From 1801, and it got off to a slow start, until by the 1970s, when photographic discoveries far outnumbered visual asteroid discoveries. We had about 170 years of visual asteroid discoveries. Likewise, telescopic visual searches for supernova in other galaxies lasted only a few decades. hitting its heyday in the 1980s and 90s with Robert Evans of Australia discovering 42 supernovae in other galaxies over 4 decades. But back to visual comet discoveries. In 1967, Dr. Edgar Everhart wrote a paper that appeared in the Astronomical Journal, which helped to answer the question all comet hunters ponder: where in the sky is the best place to find comets? The paper is entitled Comet Discoveries and Observational Selection, and it is available for download from my website, Podcast 34, Comet Discoveries and Observational Selection. Dr. Everhart was no stranger to visual comet hunting, as he discovered one in 1964 and another one in 1966. In this paper, he looked at 337 long-period comets visually discovered from 1840 through 1967. For each comet, he discovered the discovery circumstances, where it was in the sky, how bright it was at discovery, and from where it was discovered. Then, for each comet, he determined not only where each had been discovered, but also where the comet first could have been discovered, when it would have been last observed, and when it was seen best. He also compared and contrasted comets in retrograde orbits compared to those in direct orbits. Let me explain the difference. The planets all go around the sun in one direction. This is called a direct orbit. Now imagine an object going around the sun in the opposite direction. That would be called retrograde. The angle of the comet's orbit, as it intersects the Earth's plane as the Earth goes around the sun, is called the inclination. That is one of the elements of a comet's orbit. It's called the inclination. It's measured in degrees from 0 to 180. 0 to 90 degrees is called direct, while 90 to 180 degrees is called retrograde. Yes, some comets enter the inner solar system from above or below, with inclinations of, say, 70 degrees, which would be highly inclined direct orbit, or perhaps 110 degrees, which would be a highly inclined retrograde orbit. This is what the late Dr. Everhart found. 53% of the direct orbit comets and 69% of the retrograde orbit comets were found in the morning sky. That's 53 of the direct orbit ones and 69% of the retrograde were found first in the morning sky. The rest were found in the evening sky. Now, was that because these were the places that the comet hunters searched? That's what the next part of the study revealed. 70% of the direct orbit comets and 81% of the retrograde orbit comets could first have been found in the morning sky. That is to say, some comets are discoverable in the morning sky, but they escape detection until they enter the evening sky, which apparently was being covered more thoroughly. If the morning sky had been covered more thoroughly, then more of the comets would have been found in the morning sky. What Dr. Everhart also found was that between 1840 and 1967, at any time there was an average of a 50% chance that there was an undiscoverable comet somewhere in the sky that was bright enough to have been discovered. Sometimes that comet may be below the observer's horizon, as both the northern and southern hemispheres are in play here. But Dr. Everhart suggested, for an observer at 40 degrees north latitude, there's a 33% chance of an undiscovered comet in the sky, 22% chance in the morning sky, and 11% chance in the evening sky. As I began systematic comet hunting in 1975, I knew that those numbers were probably lower, as by the 1960s and 1970s there were more comet hunters out there. But I still went out there comet hunting, knowing that there may be an undiscovered comet in the area. And as a comet hunter, that was just one of the many motivations to get out of bed at 2 a.m. to go out comet hunting. So why is the morning sky favored? As the Earth goes around the sun, we are facing the forward direction in the morning. Our speed of 18 miles per second is added to the comet speed, and on the average we are approaching the morning sky comets much faster than in the evening sky. That is why the number of meteors is greater in the morning sky than in the evening sky. And it's also why you have more bugs on your front window than on the back window of your vehicle. A few more things that Dr. Everhart observed. One is that there were very few comet hunters in the southern hemisphere between 1840 and 1967. 285 of the 337 comets in this study were found from the northern hemisphere. That is 85%. That hemisphere inequality changed in the late 1960s with John Bennett of South Africa and later William Bradfield of Australia and then other comet hunters in the southern hemisphere. He also found that comets that came to perihelion on the far side of the sun are less likely to be discovered. That's known as a holistic effect. Dr. Everhart found that at least 204 of the 337 comets were found by observers specifically looking for comets. And that's probably the minimum number, with very few visually found accidentally. And here's a quote from Dr. Everhart that has always stuck with me, and I have shared it with others to explain the difficulty of seeing faint objects while sweeping. Here it is, quote, "The author has found it easier to see a 13.0 magnitude galaxy known to be in the center of the field of view than it is to notice an unexpected 12.0 magnitude galaxy which crosses a field in 2 seconds as the telescope is swept," end quote. And may I add, the object may sweep across the middle of the field of view in 2 seconds, but an object near the top or bottom of the field, as one sweeps horizontally, will be in the field for even less time. So what can we take away from this study that was done 53 years ago using punch cards and magnetic tape? If not for the automated sky surveys discovering objects that are very faint, much fainter than the amateur astronomer can visually sweep, much of it would be true today. But with the large search programs finding very faint comets, this greatly skews the results. But in the short history of visual telescopic comet discovery spanning only about 260 years, this was the reality for many of those comet hunters. This is the type of study that helped to direct comet hunters where to search. I have spent 8,663 hours visually searching for comets since 1975. 85% of my sweeping has been done in the morning sky, and all 12 of my visual discoveries have been in the morning sky. Let's talk about comets in general. The positions in right ascension and declination for the comets in our evening sky are available on Podcast 27, Comet Positions. The 3 brightest comets are found on Podcast 34, Map 1. With the moon in our evening sky, they'll be difficult to observe, but they are Comet 2017 T2 Pan-STARRS, which is magnitude 11, Comet 2020 F3 Neowise, now magnitude 9, and Comet Howl, officially known as 88P Howl, which is magnitude 10. This week the moon is in the evening sky and it will make it difficult to see these objects. Next week we'll discuss these comets in more detail. But this week we are going to take a critical look at the moon. Yes, it is nearing full phase this week, and it will be exactly full phase on next Wednesday, September 2nd at 0521 Universal Time. And that translates to the evening of Tuesday, September 1st in the Western Hemisphere. What we want to know is, does the moon really look fully illuminated when it is full this week? I say this because the moon wanders a bit. It can go up to 6 degrees north or south of the ecliptic, which is the plane that the Earth and Sun enjoy. Beginning August 31st, and for the next 4 days, the moon will be at least 4 degrees south of the ecliptic as seen from the southern hemisphere of the Earth, and 5 degrees south of the ecliptic as seen from the northern latitudes of the Earth. The question is, can you notice this? In the Western Hemisphere, both north and south of the equator, look at the moon on the evening of Tuesday, September 1st as it rises in the east. Moon rises are always spectacular, so enjoy that for a few minutes. When the moon gets higher in the sky and shows well, is all of the moon illuminated? I'm not talking about the moon's libration, that it wags and waves a bit back and forth, and specific features near the edges appear and disappear over the lunar horizon from time to time. I'm asking if it looks like a fully illuminated disk. At the angle that we are seeing it from, the north pole of the moon may not be fully illuminated. That is because we can see more of the northern section than can the sun. Can you notice any difference? With the unaided eye, I suspect that you'll not be able to tell. Then try binoculars. What do you see? Finally, use a telescope. Crank up the magnification and look at both the north and south poles. Are they equally illuminated or not? One more note. Every week after I record this podcast, my wife uploads it to the internet, and in the past has been able to send out announcements through Facebook to many astronomy clubs around the world saying, hey, the podcast is up and ready. Beginning last week, Facebook said, hey, you can't do this because it's spam. So we're not able to use Facebook in many cases now to notify you of each podcast. Rest assured that even if you don't receive a notification, typically by Wednesday morning, each new podcast, and they are numbered consecutively, will be available to you through whatever platforms you have been getting it from in the past, or go directly to my website to get the podcast and the related literature. You have been listening to Looking Up with Don, podcast episode number 34 for August 26, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ. MACHHOLZ.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky, and with the moon out of the sky, we will resume observations of some comets. And I'll talk about a comet study I did in 1985. Thank you for listening. See the sky this week. I'll see you next week.